Hello everyone, welcome to a new video. In this video, we are going to cover the NIOS Senior Secondary Course Computer Science topic Logic Gates, and this will be there for the public examination. So already we have already covered one's complement, two's complement, and number system video. Please go and check it out from the playlist. Now we are going to start logic gates here. If you are new here, I would like you to subscribe to the channel, give it a like if you enjoy this content, and do share your feedback in the comment section. Let's start. So logic gates. Logic gates, these are basically the fundamental electronic circuit that acts as a building block of digital system. So it is used to perform logical operation based on the inputs that are given to it. It uses the Boolean algebra, and these gates, logic gates that are being used, it is seen in our day-to-day life, in the telephone or in the laptop, tablets. The operations whatever take place involves logic gates. These are the building block of digital circuit, and it uses the value 0 and 1 for the inputs. 0 usually referred to as low value or a false value, and 1 is referred to as high or the true value. So we have different type of logical gates. Basically they are AND or NOT. In addition to this, we have NAND and NOR gates, which are also known as universal gates. Using this NAND and NOR gates, we can form all kind of gates. That's the reason it is known as universal gate. So logic gates usually implemented using Boolean algebra in hardware, and it is used in computer processor and all type of digital system. They can be built using electronic components like transistors, diodes, relays. Okay, these are the basic introduction about your logic gates. Now we are going to see the different types of logic gates that are going to see different type of logic gates in detail, and their circuit and their truth table and the diagram as well. So let's start with the AND gate. So what is the meaning of AND gate? It is a basic digital logic gate that outputs 1 only when all inputs are 1. Okay, so symbol, it's a D-shaped symbol with 2 or more inputs and 1 output. We will understand when we see the diagram of this one. Usually AND gate, this is a symbol that we are using for AND, that is dot, and A is the input, B is another input, and Y is the output. Once this inputs A and B pass through the AND gate, Y is the output that we get. Okay, so how is the truth table designed is, you will have, when all the inputs are 1, when both inputs are 1, you will get the solution as 1. So that's what told here. Let's see further. So this is the input, A and B are the inputs, and you can say here this is Y. Okay, so this is the shape of the AND gate, you can see, and it goes, input goes through and output is there. Output is A dot B, or you can, where in the previous statement we have seen Y is equal to A dot B. So A and B, this is a symbol used for AND gate. So this is the truth table of your AND gate when two inputs are used. Here you can see this is A and this is B. When it passes through AND gate, what the result comes. So it is mentioned that it gives you the output as 1 or high when both the inputs are 1. Okay, so you can see that is shown here, like you are having input as 1 and another input is 1, so you are getting output as 1. Whereas in the other 3 options, you can say 1 and 0 is given, that gives you the output as 0, and 0 and 1 is taken, again it is 0, and 0 0 always give you 0. So this is how the AND gate works. Remember how an AND gate behaves with the inputs. Okay, Let's move on to the next slide. So usually the use of AND gate is seen in the security system. For example, a door unlocks only if the correct key is inserted and the correct password is entered. Okay, so usually this is the example given for security system. So usually when the door is built in such a way that you have to put the correct key, also the password should be given properly. If both of them matches, then only your door opens. Okay, so this is one input, this is another input. When both are true, you will get the uh, output as 1. That means it works. Next example, you can see home appliance control. A heater turns on only if the main switch is on and the temperature sensor detects low heat. Okay, so heater works on the process where main switch should be on, and next condition is temperature sensor should have low heat, like should be cold or low heat, then only your heater starts working. So both the conditions should be true. So that this is how your AND gate works. So this is used in our day-to-day life. Two examples you can see here: industrial machines and traffic light control, how it works. So these are the two examples. Just go through this. Next one is OR gate. So OR gate is again a logical gate or digital logical gate, you can say, that gives an output of 1. The OR gate is a basic logic gate that gives you the output as 1 if any one input is 1. Okay, the other input can be 0, then also you will get the output as 1. Based on this logic, systems are designed. Okay, now you can see here output is 0 only when all the inputs are 0. So it is not like your AND gate, it is different from your AND gate. Okay, so symbol of OR gate is this. You can see here the plus. This is the OR gate symbol. And A and B are inputs, and Y is the output that gives the output. Usually it is shown as Y. Please see the diagram. So here A and B input, and the shape is like this. It is not similar to your AND gate. Here you can see a curve and how it is joined here. Look at the OR gate truth table. As told, any one input is 1, the output will be 1. Any one condition should be true. Here you can see 0 and 1 inputs are there, so output will be 1. 1 0 1 1 1 is 0. The only condition when it not work is both the inputs are 0. That means both the inputs are false. Okay, let's see some examples or applications of your OR gate. So, lighting system. A lamp can be turned on either by switch A or B. So usually in our homes we can see, to switch on a lamp or a light, we can turn it on from any one switch. If you have two switches for the same light, if any one switch you use, that here you can see the example of an OR gate. Any one switch you are using, either switch 1, switch A or switch B. Okay, another one is alarm system. An alarm system, when it rings, alarm system rings when the sensor detects fire, smoke or gas anywhere which is placed inside a house. A house can be it can be in the bedroom or it can be in the kitchen. Anywhere if it detects the fire, it will show you the output. It will start working. Again, the next example comes is elevator safety or elevator doors usually open when you press the inside button, it opens, and if you press outside button also it opens. So any one condition is true. In that case, the elevator door opens. So that is again an example of OR gate. Also other two examples are given. Please go through this. Next comes NOT gate. So NOT gate, as the name suggests, it is whatever is the input, output will be opposite of that. Okay, you can see here output is y, and whatever is the input, it will have only one input, and the input will be turned to or inverted. As you see in the expression, y is the output, and whatever is input given, opposite of that will be the output. Okay, let's see the next diagram. You can see here, this is the symbol of your NOT gate. It is different from your AND and OR gate. You can see a kind of triangle here and also a NOT, okay, here in front of this. So this is input A, and the input will be inverted. So this is how it is represented. Let's see in the next one. Truth table, how it looks. So it has in one input 0 or 1, and the opposite will be the output. You can see in the diagram itself, 0's output will be 1 and 1's output will be 0. Now the application. Usually the application where we can see this one is light turns on when it is dark. Okay, so this is an example of your NOT gate where sensor becomes 0, and that time the light goes high or becomes 1. Can represent 1. So next example is off. That means when daylight is there, so sensor is considered as 1. So in that case, light is turned as off. So no need to switch on the light during daytime. Okay, that's the meaning. And now NOT gate inverts the sensor signal. That is very clear to you. See this example of temperature sensor. It gives output 1 when the room is hot and 0 when room is cool. So these are the examples. Please read the other example also. Next one is NAND gate, usually referred to as the universal gate, and it is formed by using a NOT gate and a AND gate. So from that the name came as NAND gate, and for NOT and AND gate is there. So combination of these two. So output is 0 only if the inputs are high or 1. For all the other input combination, output is 1. Okay, we can see this using our truth table, but it is very clear whatever is the output of AND, opposite of that will be there as the final output. Expression is given like this: A and B dot represents AND. So A dot B is AND gate, and on top of that you can see a NOT symbol, which gives you a NAND gate at the end. This is the symbol, how it looks like. This is AND gate and a NOT is put. So together it makes a NAND gate. Okay, this is the expression, or you can see from the diagram how it looks like. To see the truth table, see here 0 and 0. For AND it will be always 0 if any one value is 0. For becoming or to get a 1 value or high value, input should be both 1. So this is our AND gate, which you have already learned in the previous AND's truth table. Now you want to see what is NAND. So whatever is the input for your, like now we consider this value to be converted to or inverted. So in that case, 0 becomes 1, 0 becomes 1, 0 becomes 1, and 1 becomes 0. That is how the result looks like. So though input is like this, output looks like this. Next, application of NAND gate, usually universal gate. You can see application is building other gates, any other logical gates like AND, OR, NOT, NOR, XOR, XNOR. These can be built using this NAND gate. Digital circuit, widely used in processor, memory units, and control circuits. Next comes NOR gate. Now we have learned about NAND gate. Similarly, now we are going to see NOR gate. It means OR gate, and we are going to use a NOT in front of that. Okay, so you can understand now how it will maybe looking like and how the expression will be like. You can see here the expression where A and B OR gate is applied, and then a NOT gate is applied to it. So it is formed by connecting a NOT gate to the output of an OR gate. Output is 1 or high only when the inputs are 0. So we can see it using our truth table. If any input is 1, the output becomes 0. So no need to remember this completely. You can just use your truth table and find out the result. Now this is the symbol looks like. This is OR gate and a NOT is put here. So this here comes your output and inputs are A and B. Truth table looks like this. So input is A and B and output for OR will be any one value becomes 1 should give you a 1 as the result. So here you can see 0 and 1 output should be 1. 1 and 0 output should be 1. 1 and 1 output should be 1. Okay, so this is very clear to you, I guess. And then comes your NOR gate. That means whatever is the result here, everything gets converted to the opposite. That means 0 becomes 1, 1 becomes 0, again 1 becomes 0 and 1 becomes 0. So this is the final output of your NOR gate. And here you have inputs as A and B. So this is how your truth table of NOR gate looks like. Now what are the uses you can see, and it can be you also used to build all other logic gates. These are the basic gates that are there. Digital circuits, and it is also used in processor, memory units, and combination sequential circuits. Alarm system also this can be used. So we have covered the logic gates in this video. We have already previously covered 1 and 2 complement and the number system conversion, everything. So if you are from NIOS background, NIOS senior secondary course, if you are using, please do refer to these videos. Other students who are looking for binary logic topic, this is also useful to them. So don't forget to subscribe to the channel, give it a like if you enjoyed this content, and do share your feedback in the comment section. Thank you for watching.